And I wanted to say thank you to the National Water Quality Monitoring Council for supporting the Volunteer Monitoring webinar series. And just a little bit of background on the Volunteer Monitoring Work Group of the Council. It was approved in 2016 with the goal to better integrate volunteer monitoring activities with ongoing water quality monitoring conducted by local, state, and federal entities. And central products of the work group include collaboration and outreach through articles, submissions to the council newsletters, and webinars like today's to explore key topics of interest to the volunteer monitoring community. Today, we're really excited to highlight and feature the NOAA Sea Grant programs. And I didn't know until March that NOAA Sea Grant has more than 80 citizen science programs underway in coastal and Great Lake regions. And this webinar will highlight the protocols, the participants, and the key findings associated with 3 unique Sea Grant projects: marine debris in Alabama, Mississippi, extreme tides monitoring in Southern California, and beach profiling in Maine. And it will also include an overview of NOAA Sea Grant's vision for citizen science and opportunities to get involved. So as Candace said, general housekeeping. If y'all have questions, we encourage you to submit those questions in through the chat function, and please direct them to all panelists. And for our agenda today, we'll get started with an introduction to NOAA Sea Grant and then going through the program spotlights, leaving about 15 minutes for Q&A at the end. So today we are joined by 4 fantastic people: Monique Myers, Mandy Sarton, Holly Ringe, and Kristin Grant. And to get started, I'm going to hand it over to Monique Myers, who is the Sea Grant Extension Specialist at University of California, Santa Barbara, and she works with communities with resilient coastal communities in California. And Monique, I will hand it over to you.
Okay, thank you, Julie, and thank you, Candace. And we want to thank the National Water Quality Monitoring Council for hosting this webinar with a focus on Sea Grant. I'm in Santa Barbara, California, and this is a picture of an area right around the corner. And just to give you a little background on Sea Grant, we're a 50-year-old organization established in 1966, and we exist in every coastal state in the United States, including territories, a couple territories, and the Great Lakes is included in coastal states. We have, as Julie said, over 80, approximately 86 active community or citizen science monitoring programs, and Sea Grant as a whole actually has hundreds of thousands of volunteer hours every year. And so next slide, please. And so just to give you a little bit of background of where we come from, we are housed in the federal government as part of the National Oceanic and Atmospheric Administration, and we exist through partnerships with universities. We have 33 university-based programs, and we really focus very much on place-based. We are very place-based and focus on local communities. We do very applied work on coastal and marine environments. And we work in the private sector with all different groups such as fisher folk, with states, and we have many partner institutions that we work with. Next slide, please. Okay, and so our approach is to fund scientific research, and we bring scientific research to the public through extension and education. And so I am an extension specialist, as are other folks on this call that you'll be hearing from today. And we have about 500 extension agents like myself throughout the coastal U.S. and territories. And one of the things that we do through extension is involve the public in research. So the next slide, please. I just thought you might like to see the focus areas that basically are the umbrellas for almost everything that we work on. We have healthy coastal ecosystems, resilient communities and economies, sustainable fisheries and aquaculture, and environmental literacy and workforce development. And that pretty much covers everything we do. And next slide, please. And so I just wanted to close that brief introduction to Sea Grant with a view of the world, and all the different dots represent a Sea Grant program. And the world is tilted because we have Guam all the way out there. And so I think we've been thinking a lot about our citizen science programs at Sea Grant lately, and I think we're really well positioned to work nationally and internationally with the citizen science or community science community, and we're excited to work with groups such as the National Water Quality Monitoring Council, and ALARM, and others who have a really strong focus in this area. And without further ado, I will let you hear about some of our great programs that are going on.
Fantastic. Thank you, Monique, for that overview on Sea Grant. And just a reminder to everyone who has joined, if you have questions, please write them using the chat function and direct it to all panelists. Okay, so moving on, I'm happy to introduce Mandy Sarton, who is with the Alabama-Mississippi Sea Grant, and also weathering Hurricane Gordon right now. Mandy graduated from Southeast Missouri State University with her BS in marine biology, and currently works for the Mississippi State University as the Extension Program Assistant and affiliated with the Mississippi-Alabama Sea Grant as a marine debris specialist. And we look forward to hearing more about that, Mandy, with your presentation.
Yes, thank you for that awesome introduction. Yeah, so today I want to talk to everybody about what Mississippi-Alabama Sea Grant is doing whenever it comes to involving citizen scientists in current marine debris research. So this project was actually funded by GOMA's Gulf Star Grant, and by, I think, January of 2017 is when it started. Mississippi State was awarded the grant, and this project will actually go through December of 2018. So we're actually coming up to the conclusion of this grant, which is kind of sad, but I believe Mississippi State and all other partners will kind of continue on the education and the awareness that comes with this project past its end of funding. But within this project, citizen scientists are collecting and analyzing samples for microplastics, which we will dive into a little bit later. So we'll go ahead and get started with the next slide. So if you haven't heard about marine debris already, marine debris is defined as any persistent solid material that is manufactured or processed and directly or indirectly, intentionally or unintentionally disposed of or abandoned in the marine environment. That is quite a hefty definition for basically just trash that is in the water. It is a global issue that is significantly reducing the quality of life in our coastal environments. And so the increase in all this discarded trash, along with the very slow degradation rate that comes with its characteristics, is leading to a gradual increase of marine litter that is found at sea, on our ocean floor, and along the shore. So as you can see in this slide, I put a couple statistics that are actually just kind of estimates of what we're going to see in the near future. So by the year 2020, it is estimated that 99% of all seabirds would have ingested marine debris at one part in their life. And then by the year 2025, which is just around the corner as well, the total amount of plastic debris in our ocean will triple to 150 metric tons, which is way more than what we saw in 2015. So our plastic production is increasing with its supply and demand. So plastic is such a durable, inexpensive material that we are using every single day, and that it is just accumulating in our environment. And so one increasingly abundant type of plastic marine debris that we are currently super focused on is microplastics. A microplastic is a piece of plastic that is smaller than 5 millimeters, and it consists of different shapes and different sizes below the 5 millimeters, including microfibers, microfragments, films, and microbeads, which I'm sure you guys have heard of at least a couple of these examples of microplastics. Microbeads are something you find in your face wash, in your cosmetics, body wash. Microfibers are a form of plastic that shed off clothing whenever you laundry them. So those are just a really intense target point of this entire project. So when this project actually got started, we were super curious about how much and what kind of microplastics are currently in the northern Gulf of Mexico. And knowing this information can help when it comes to developing possible prevention methods. So we'll go to the next slide and we'll talk about some of our project goals. So one of our overall project goals is to get just an estimated abundance of microplastics in the northern Gulf of Mexico. There are no current large stats of this data, so this is kind of the first little baseline data that we are getting with this project. And so next slide. Other project goals include awareness. We want to increase awareness and education of marine debris issues. And we do this by connecting with and involving the public and within this citizen science-based project, which is super awesome. So if anything, I want people to get out of this project is just education and awareness of what's around them. So also with this project, we are developing education materials to be distributed by our project partners and other trained volunteers. So that leads us into my next slide, where I want to chat about our partners. So without our partners, this project would not be possible. We have some really awesome proactive partners just scattered across the Gulf of Mexico, all the way over in Corpus Christi, Texas, all the way down to Key Largo, Florida. And so this collective team contains representatives from each state who are currently engaging many different stakeholder groups with marine debris education and outreach. So our next slide. So the big bulk of this project is to get the citizen scientists really involved with almost identical research that scientists are doing out there. So what am I? So partners work with citizen scientists to collect and analyze water and beach sediment samples for microplastics. The partners will train citizen scientists to go out to their local beaches or local waterways and collect a liter of water or a bag of sand that they will analyze later. And so on this slide, we actually have examples of what they are finding. So microplastics are a huge environmental problem, and they're prevalent in our coastal sediment and water off the Gulf of Mexico, and this is exactly what this analysis is providing us, like all this data. And so you can see that we're finding from the left to the right, we're finding films, we're finding fibers, we're finding fragments, and we're finding microbeads. So all of this awesome data that all these partners are getting, we are putting into a beautiful little map, which is on our next slide. So this is an interactive map that we created showing the microplastic abundance and samples submitted by our partners. If we can flip to the next slide real quick. You can see that if you hover your mouse over this map, it gives you all the yummy, juicy details of the data that we are collecting, the location, the date, the time, who collects it, what kind of microplastics we're finding within these samples. And so this data is presented in a size and color gradient. So the bigger the size of the circle and the darker the color of the circle means the more microplastics we are finding. And so this map is available to the public. Actually, if you guys go to coastal.msstate.edu/microplastics, you can play around with this map and get some pretty cool data from it. So throughout this project, we had 2 mandatory samplings for partners. So one was last year's coastal cleanup event, the International Coastal Cleanup Event, which in most places takes place in September, I think the 3rd Saturday of every September. We're really unique here in Mississippi, and we actually don't have our coastal cleanup until October. But so last year in 2017, every partner that we had collected water and beach samples on their coastal cleanup, and they analyzed them, and this is what we are seeing from those events. So this is just a snapshot of microplastic abundance within just a little window of time. So this is some pretty awesome data we are getting. So if we could go to the next slide.
And Mandy, you have 2 minutes.
Okay. All right, so what are we finding so far? So we are finding that the biggest chunk of microplastics that we are finding are actually microfibers. So we're finding 90% of water sample microplastics are fibers, and then 60% of our sediment sample microplastics are fibers. And so we are also finding the highest overall concentration of microplastics in Texas. And so this project doesn't conclude until this December, and we have this September's cleanup coming up. So we are still anticipating more sample submissions from partners within the next couple months. So it's going to be super exciting. Then my final slide. So yay, this project is an education-rich project, and the citizen engagement continues to grow. Every single day I see it here in Mississippi and over in Alabama. The increased education and awareness involving marine debris and microplastic that comes with this project really utilizes and emphasizes the importance of citizen science. And so by involving citizens in informative scientific research, we are actually filling a real knowledge gap that we have when it comes to microplastic sources and accumulation. So with marine debris being such a large and global issue, it's really awesome to get communities involved in something this big and worldwide and just kind of start the change that this environment needs to stay healthy. But if you guys are interested in getting involved with this project, please email me and I can send you many more details that I wasn't able to go through in such a short time with such an amazing project. But that's all I have.
Fantastic, Mandy. Yeah, microplastics is a hot topic, and I'm sure we'll get lots of questions about that. Speaking of questions, if you have questions, please submit them using the chat function and direct them to all panelists. And Mandy, as we move into Holly's presentation, if you could include the URL for the map, that would be fantastic.
Yes, definitely.
All right. Great. So moving on, ready to introduce Holly Ringe. Holly is the Communications Manager for the Sea Grant program at the University of Southern California. Holly develops communication strategies and materials and coordinates USC Sea Grant communication efforts across projects, programs, and digital media platforms. She is engaged across the spectrum of ocean and coastal issues facing California and specializes in the interplay between marine science, policy, and communication. Holly, take it away.
Hello, everyone. Thank you again, Candace and Julie, for inviting us and hosting this webinar. Today, I'm pleased to present an overview of urban tides, and this is a program where you can help document the impacts of rising sea levels on your beach communities. And the data is used by scientists, by city planners, by educators to help Southern California understand and prepare for sea level rise. Now, in Southern California, we have millions of people living by the sea, millions of homes and businesses, and planning for sea level rise is a priority in the region. Los Angeles in particular has a lot of infrastructure that sits only about 10 feet above sea level. So things like sewage treatment facilities, power plants, and roads. And the roads include main evacuation routes out of the area and trucking routes that deliver billions of dollars in goods from the ports. So all of these things will be impacted with rising seas. Next slide, please. Okay, so briefly, I just want to provide a bit of context on sea level rise. In Southern California, it's expected to match global projections with an increase of 5 to 24 inches by 2050. That's within the next 30 years. And just 4 to 8 inches of sea level rise will more than double the frequency of serious flooding events in the region. And in Southern California, we're not just talking about sea level rise. The impacts that we're going to see are from sea level rise in combination with high tides and storms. So the waves and the surge, these things are going to cause the most damage. If you're looking at this graphic, the blue lines represent current sea level and then the elevated water level with the tides and storms. And the red lines represent sea level rise at mid-century. And again, you can see how much further the water goes up with the combination of sea level rise, tides, and storms. Now, in addition to the flooding, sea level rise will expedite many natural processes that already occur. So we're talking here about beach loss and cliff erosion, things that we see within a normal season. And essentially what I want you to take away is that elevated sea levels mean elevated risk. And the impacts that are listed here, as you can imagine, also have a large socioeconomic impact. Next slide, please. All right, so moving into the Urban Tides project, why do we want pictures of this now? It's because the flooding and erosion are already happening along our coast. It's being driven by king tides, which are extreme high tides that happen naturally a few times a year, and also by winter storms and by El Nino. And these events give us a glimpse of what the future impacts of sea level rise look like in our beach communities. For example, the high water level that we see with the king tide today, this will be the level of a normal high tide with future sea level rise. There are beaches today that disappear completely underwater during king tides. And these beaches will disappear daily during a normal high tide with sea level rise. And this will be a loss of use for people and wildlife. So by capturing images now, it helps us to visualize the risks that we are facing, and it helps us prepare. We can identify locations and people who are vulnerable, and we can provide the data to help make the models projecting sea level rise more accurate. And if we know who, where, and what is vulnerable, we can set priorities for planning and allocating resources, and we can advance the dialogue about how we're going to adapt. Next slide, please. All right, so this is how Urban Tides works. We ask folks to go to beaches, to estuaries, lagoons, and cliffs, and take photos of extreme tides, erosion, and flooding. We've tried to make it really simple to participate, and at the moment, we're in the middle of upgrading to a new database platform, so I can't show you the app that we use or how we display the photos, but essentially you would use the app to take a photo, and most of the metadata, like the time, the date, the location, is captured automatically by the app, and it uploads directly into the database. And Urban Tides differs from some other king tides projects in that we have established scientific protocols. These were developed by scientists at the U.S. Geological Survey, and these ensure that the data in the photos is accurate and useful in scientific research. So if the protocols are followed here on this slide, scientists can determine the water level shown in the photo. Next slide, please. All right, so the images then are used in different ways. And one of the ways is to help ground truth scientific models that project sea level rise and erosion. Scientists at the U.S. Geological Survey have created a modeling system called COSMOS, the Coastal Storm Modeling System, and it predicts coastal hazards from a range of 40 different combinations of sea level rise and storm intensity. So the models show hazards like where flooding will occur, how deep the flooding will be, and how long the flooding will last. And these models are then output as interactive flood maps. An example is here on the left, and the map shows flooding for 5 different levels of sea level rise in combination with a severe storm. And if you can see the turquoise and green dots, these are locations where we have Urban Tides photos. And the orange arrow is pointing to the location of the photo here at the right. And so then from the images and the data that we collect, scientists can see what is happening on the ground. And they can calculate the exact water level at the time of the photo and use it to calibrate the COSMOS models, helping to make them more accurate. And the COSMOS models are now being used by more than a dozen coastal cities in Southern California, including the 4 largest, so Los Angeles, San Francisco, San Diego, and San Jose. They're also being used by 9 California state agencies to help advance sea level rise planning. Next slide, please. All right, here's another project. There's a team at NASA called the Southern California Coastal Disasters Team, and they're located at the Jet Propulsion Laboratory, or JPL. And they completed a project this summer that increased the accuracy for one aspect of the Cosmos models. The team used new sources of data, which was imagery from NASA satellites, radar imagery taken from an airplane, and urban tides photos, and used them to improve the flood extent mapping. Essentially, this means how far does the flooding extend landward in from the coast. So we were able to coordinate about 50 urban tides participants to go out and take photos during the same time that the radar airplane was flying over Southern California. And we got 250 new photo records from this, from Santa Barbara all the way down to the Tijuana River estuary. And these photos provided really invaluable on-the-ground comparisons to the radar imagery. And this helped reduce error and uncertainty in the model results. And I love this as an example of how citizen science can enrich data gathering and lead to more robust results. Next slide, please.
Holly, you have 2 minutes.
Thank you. So the urban tides photos have also been used for other research. And just one more example is that scientists at Scripps Institution of Oceanography in San Diego used them for research on extreme weather events like El Nino and winter storms. And the photos help them identify and confirm coastal erosion and damage to infrastructure that they had only seen from aerial surveys. Okay, next slide, please. Now, this is one of my favorite ways that urban tides is making a difference. All the records are accessible to the public, and we have more than 1,000 photos now that we use throughout a host of programs to help increase ocean and coastal and climate literacy. Just a couple examples. We include photos in presentations and when we work with city planners, and we've integrated urban tides into educational programs at schools and informal science centers like aquaria and for naturalist programs. Students, as we know, will be the most impacted by sea level rise and climate change. And so urban tides provides them with a first-hand experience in collecting data and helps provide a really critical understanding of what it means to be an engaged member of the community. And another really important part of urban tides is building relationships between scientists and the community. We hold beach walks that bring together the scientists, the city planners, recreational ocean users, students, coastal residents, teachers, and they've been very effective at strengthening participation and creating discussions about how to adapt to rising seas. Scientists that come, they get to learn about local priorities directly from the community, and urban tides participants get extra training on the program, and we talk more in depth about sea level rise through the flood maps, through the photos, and talk about natural options for adaptation, things like sand dunes and living shorelines that can help. Next slide, please. All right, and these are some of our urban tides citizen scientists. And I really just want to stress that science is a resource for everyone. And at its core, urban tides is a way for individuals to engage in meaningful science. Your observations really do matter. It's a way to raise public awareness and create a discussion at the community level about sea level rise, both the impacts and ways to adapt. And equally important is that citizen science programs bring more voices into science. Next slide, please. Okay, and this is my last slide. So finally, just please feel free to visit the website and reach out to me with any questions. Thank you.
Wonderful. Thank you so much, Holly. And again, these presentations will be saved on the Council's website. So these URLs that are included, you'll be able to access in the PDF uploaded after the webinar today. Now let's move on to Kristin Grant in Maine. And so it's my pleasure to introduce Kristin. As a Southern Maine Marine Extension Associate, Kristin has worked with Maine Sea Grant and University of Maine Cooperative Extension since 1999. Her work focuses on coastal community development and includes a range of activities to build the capacity of coastal communities to plan and adapt for their future, including managing the Southern Maine Beach Profile Monitoring Program. Kristin, take it away.
All right. Thanks a bunch, Julie. Appreciate it. And so as Julie introduced me, I'm Kristin Grant with Maine Sea Grant and University of Maine Cooperative Extension. And yes, you're seeing that right. My last name, my organization, the same. Very happy coincidence. And I'm going to talk to you today about the Southern Maine Beach Profile Monitoring Program, which is an effort to engage community members, and it's a research program that's designed to generate information to help guide beach management. And I know you're probably also thinking, does Maine have beaches? But yes, in fact, it does. 2,300 miles of coastline, about 1% of which is sandy beach. And also interesting part of our beach profile monitoring program is it's been adapted as a model in California and New Hampshire, and actually the Yucatan region of New Mexico. So you heard from Monique Myers earlier, so the program has been taken there to California. So next slide, please, Julie. All right, so a quick definition of what beach profile monitoring is in case you're not familiar with it. So it's a simple surveying technique that's used to measure the contour of a beach. And we didn't invent the method that we use, but it's super simple, really easy in terms of materials and in terms of using volunteers to execute the method. It was developed in 1961, so it's also not a new method, not cutting edge technology, but it was developed by K.O. Emery at Woods Hole Oceanographic Institute in 1961, so it's called the Emery method. And this is a good shot of how the method works. So it involves using 2 wooden stakes that are 1.5 meters long, and they're connected by a 3-meter rope. And the basic idea is that the woman in the red there is the sighter, and she's looking out to the horizon, so you need a clear view of the horizon, and then matching up the horizon with the lower of the 2 stakes, and then drawing out that line until it reaches the higher of the 2 stakes, and then the stakes are measured in centimeters, so you find the data point on the higher of the stakes, and that's how the data points are collected as you move, sort of leapfrogging that 3 meters at a time from the top of the dune to the low water line. So the roles here are sighting, which is the woman in the red. The man in the gray here is doing what's called aligning. So he's sighting backwards up the dune to ensure that the approach down the beach is going in a straight line. So there are stationary markers in the dune that he's lining up the 2 posts with. So that's the method itself. And Julie, we can move on. All right, so we'll talk for a second about the need for the program. So if you're a New Englander, you know the language of the blizzard of '78. This was an extremely harsh nor'easter that we had in February of 1978, and in some cases, beaches still haven't recovered from that storm. Major, major losses to Maine's beaches, and in response, the state of Maine developed what we've come to know as the coastal sand dune rules. Those rules were among the most restrictive in terms of building in dunes in the country. And naturally you implement regulations like that and you expect some level of pushback. So they generated over the course of the next couple of decades quite a bit of conflict between property owners in the coastal beach areas, regulators, and scientists. So the program was established in 1999 in hopes of making progress in terms of beach management by engaging those 3 different types of stakeholders working together in this program. And I'll just focus us here for a second on the picture that we're looking at, which is of one of the most erosive sites in all of Maine, in Saco, Maine, where you can see a tube, it's called a geotube, that's filled with sand that has been used here in an effort to allay some erosion at that site, but as you can see, it's not working terribly well. So we'll revisit that site later in the presentation. So we'll move on, Julie. All right, so the goal of the program is to develop a record of beach change in order to promote understanding of coastal processes here in the regions that we monitor. And that understanding helps to inform beach management decision making. But even beyond the the obvious connections to data and the implications for using data, we're also trying to develop a network of trained volunteers who are knowledgeable about beach issues in general, but also knowledgeable specifically about the changes that they see on their own beach, so that they essentially become liaisons between their beach and their community. So next slide.
Sorry about that.
Okay. There we go. All right, so now we'll talk a little bit more about the method. You know how the siting and the alignment is actually done, but let's talk about how we implement it here in Maine. So in Maine, we have 15 different beaches that we monitor. We'll see that in a second. So we have 15 teams of volunteers that are working on the beaches, and they have one team leader who's the contact for the program itself, and they tend to have roughly 4 volunteers that work with them. They monitor 1 time a month, and really importantly, they monitor all year long, 12 months a year, so that means even in the depths of winter here in Maine, they are going out there, and it's actually the most important that we get that information in the winter, since that's when we see the most dramatic change. They monitor on the lowest tides of the month for the obvious reason that you want as much of the sand beach exposed as possible. And there are roughly 4 profile lines per beach, so 4 different locations where the monitoring is taking place from the top of the dune to the low water mark. The program recommends a time period of 3 days per month for all those teams to get out in the field and collect their data, so that we're looking at a snapshot in time. And as I mentioned, you need a clear view of the horizon, so you need clear skies, and also we have an online data system, so the data is entered directly by the volunteers into our online database, which makes it available for analysis by Maine Geological Survey, which is our primary data user. Next slide.
Kristin, you have a minute left.
Okay. All right, so our program area, as I mentioned, is those 15 beaches in the southernmost section of Maine. You can see it on the inset map here, and we'll go on to the next slide. And the program absolutely would not be possible without our 120 volunteers. There's no capacity at the state level to run a program anything like this expansive. So we have coastal property owners, recreational beach users, conservation interests, and teachers and students that are involved. And we'll look at our partners just briefly. Next slide, please. Another important component of the program is that the long-term funding is provided by the participating cities and towns. So they have built in funding to their annual budgets to participate in the program because they understand the value of the data. And I've already mentioned the roles of some of our partners here. Another one I'll mention is the Wells Reserve which is a National Estuary and Research Reserve, and we share a joint position for volunteer monitoring. And I'll just talk quickly, if we move to the last couple of slides, Julie, about a partnership that we have with the National Weather Service, which really constitutes a success story for the program. So we'll move along to the next slide. The National Weather Service uses our volunteers to call out on pre and post storms. So in addition to their regular monthly volunteering to monitor, they'll also be called out when we know that there's going to be a storm by the National Weather Service. So they collect their data just prior to the storm and just following the storm. So remember, with that GeoTubes site in Saco, this is prior to and after a particularly bad storm in April of 2016. So the next slide, please. And here's the data that was generated through the National Weather Service to look at that area where the erosion was so extreme in that area of the GeoTubes. And we'll look at the next slide, and we'll wrap up. So the data that was provided by the program and the monitoring volunteers was used by the state and the city of Saco to make the decision that the erosion is so extreme in that area that their decision has actually been made to remove Surf Street, the street that you can see in this picture, and to replace it with a dune system. So a really good example of how the data gets used on a daily basis. And now that we have nearly 20 years of data, the importance of maintaining the program is only becoming more and more obvious. And that the partnerships are absolutely critical to keeping our program going. So thank you.
Awesome. We've seen a couple of questions appear in the chat function to all panelists about some of the URLs for the different program areas. So here's a snapshot of some of those URLs. And again, a PDF of the presentation will be uploaded to the council website, and you'll be able to access those links as well. So yes, so if you have other questions, please submit them to the chat function.